Okay, last time we had some problems with differential equations. I probably skipped a step in doing this. In uh, we talk about a set and operations and equations, right? Set is take a number, there's nothing here. Operations is like, for instance, you do you have y equals to fx, right? It's a function,
Yeah.
and then you say you do dy dx that that equals to a different function, right?
Uh-huh.
Or you can do it this way. You can take an integral of this fx, right?
Yeah.
It equals to another function. This is sort of always so. You give a function, it'll do it. However, if you say this function y equal to fx equals to x plus 1, this is a constraint you put in, a restriction, so to speak. For instance, if you have however many apples you have, I have one more. And this is that expression. It doesn't have to be one more. I can have two more, whatever. But just in this case, I have one more. Let's say I'm 1 year older than you. I'm always 1 year older than you. Whatever. Well, because I'm many more years older. But let's say I'm 1 year older than you, right? It doesn't matter what your age. Let's say our birthday is the same. It doesn't matter your age. I'm always a year older, right? But I don't have to be like me to you, right? It's many years older. This is the certain constraint you put in. There's a limitation you put in. That's called equation, right? It doesn't have to be in this form. It could be just you can write this together like that, right? In other words, in this case, x minus y plus 1 equal to 0, right?
Yeah.
Same thing. There is a relation between x and y. However you write this, yeah, it's a constraint. There's a limitation. When you say this, right? You say there's a limitation. Let's say you say something else. You say something else, right? That's another limitation.
Yeah.
This is a line. This is a line, and those two lines. There's one point that they cross. There's a solution to that. Yeah. Can you see the solution?
Yeah, it's negative 1, 0.
Okay. At this point, they cross, right?
Yeah.
This is common to both of these, right? That's equation. So when I say dy dx equals to, say, minus y, right? That's an equation, a limitation. In the situation like, what do we talk about? In terms of minus, that could be the air density. It could be, what else? Radioactive decay. It could be
Bacteria growth or death.
no. Bacteria growth is, well, yeah, yes. When this bacteria growth is positive growth. So in other words, this comes down like that, and this goes up like that. Yeah. Typically, we don't have minus time. We're just starting from this time. In terms of bacteria, this is how many bacteria we have. It goes swings up very, very fast. This swings down very, very fast. This is called exponential relationship. Or in bacteria investment, we talk about investment many chapters, sections ago, and you just wait, and then once it go exponential, there'll be a disaster. In terms of bacteria, there'll be so much bacteria going. Have you seen you obviously you haven't seen the insects attacking a wheat field? Actually, the sun is blocked out. There's so many of them. It's an explosion of population. This exponential growth. When they have a lot to eat, when everything, all the conditions, temperature, whatever, water, everything is there, right? All the conditions there, they have exponential growth. That's why when we have an infection, you need to get it under control relatively fast. You don't want it to really get out of hand. But of course, if you use antibiotics too much, then your body, the bacteria in your body can have a resistance. Learn how to deal with it. But those are the two equations you can write in response to it, and then you can find what's the best place to do it. In other words, not when you have the least amount of inflammation, then you will put antibiotics into you. In any case, this is this basic relation represent a lot of phenomena in the world, where we are out of this. How do we take a derivative, or how do we take an integral? We're getting into solving like real world problems. And in order to solve this, now we have this, right? Last time we look at the field of dy dx equals to x, right? Now this is equal to y. Let's just do the positive y, right? Well, let's take a look at this. Okay, this time I'm smart. So this is the 1, this is the 2. I'm not going crazy with this. This is the 1, this is the 2. Right? 1 and 2. Okay. Oh, by the way, let's only do the positive part of this. Y, this is the y, this is the x. Okay, dy dx equals to y. So on this line, there will be the same slope, right? On every line, there will be the same slope. This slope is 1, right? This slope is 0. Here is all 0, right? Here is 0, right?
Yeah.
And on this half line is like half, which is about this, like this. This is half, right?
Well,
Wait a minute.
Half.
That's negative. Okay, let's do the negative y then. Sorry, that's wrong. The negative half, right? And this now is a negative 1. I can't change again. Okay, this is negative 1. This is negative 2. Let's call this negative 2.
That's really steep.
Okay. So in other words, when we look at this, right, it goes very, very steep, and then it evens out. Every time you do half of it, the slope goes to half. In other words, here it'll be a quarter, here it'll be 1/8.
Yeah.
It'll never touch this point, this line.
Except you did 0.
Yeah, we did 0, but I mean, if the initial condition is on this line, it'll be just always 0 down. However, if the initial condition is on here, every time you move down, it's only gonna go half. It'll never actually touch this line. It'll just approach this line as it go down.
Okay.
Like in a sort of radioactive situation, it'll never go to 0. It'll go down, sure, yeah. After a certain period, it'll go to half. Then after the same period, it'll go to another half, 1/4, 1/8, 1 or whatever. It'll never go to 0. So when we're talking about if you have nuclear waste and you wait for 50 years, I forgot the half-life, the radiation go to half, right? You wait another 50 years, it'll go to 1/4. Wait another 50 years, it'll go to 1/8. Wait another 50 years, it'll go to 1/16. And all you're gonna do is just half and half. It's never gonna 0. Of course, you wait so many years. In the end, there will be one nuclear that's still in a sort of excited state, right? Can go through the decay and then go through the decay, and then you have none. But theoretically speaking, you have a radioactive waste, right? It'll be always there. Yeah. Okay. Now, let's see how much time we spent on this. 9 minutes. Okay, we're gonna do one step further. Okay, does this all make sense? Okay,
Yeah.
Let's just repeat what we did last time. To solve this equation, right? What's this? What's the equation of this?
It's like e to the power of
X, right? What about this?
e to the power of negative x.
Right. The negative came out, right? Good. Did you remember it, or you actually saw it from this?
Well, I just know it.
Oh, you just know it. Okay, here's the thing. When it's actually whatever the constant that's multiplied to it, you don't know how to do it, so you do a d minus x dx. Then that'll come to this. But on the other side, you need to do the okay. You need to do one of these, right? You do this d minus x, right? And then you do d minus x dx. This is minus. In other words, whatever the constant that came out, right? This equals to minus e minus x. Whatever is the constant there, it came out to on the lower, not on the upstairs anymore, on the downstairs. Yeah. You remember how we solved this last time? Okay. Okay. Let's just talk about this constant. And also there is a situation, there is something about the negative side of it, but we're not going to get to that. You said something about the absolute value of y, right?
Yeah.
Log absolute value of y, right? That's actually true, but since we're just sort of going through it, let's just not worry about it. Let's see. Let's do one of these. Watch this. dy. Let's say dt. Let's change your variable. Okay. Rk is our constant. Okay. Now instead of just a y, now I have a constant. Okay. Can you do it, or you want me to do it?
Don't you just take out the constant stuff?
Take out the constant. No, that comes later. Now you have to solve it. You in other words, y on one side and dt on the other side, so you can take an integral to take out the dy dt. You have a dy dt here, right? You want to take it out, right? And here the y or whatever. I just do it, so you see it again. Okay. This make sense?
Yeah.
Okay. Oh, I do the same thing. I'm not gonna do dy anymore. I'm gonna do dy ry plus k. dy ry plus k. Right?
Yeah.
And this obviously is r. When I do this, this does not equal this.
Yeah.
K will go away. When you do dk, it'll go away. Because 0. But the r will not go. So I have to multiply 1 over r, right?
Yeah.
Doesn't make it equal. Then it equals dt, right? So when I do this, let me in this case, let me put the absolute value in it. Ry plus k equals to t plus c, right? Does that make sense? I put the constant in. I put this is more like a correct answer. C is any constant because we take an integral that come out and produce a constant, and this is absolute value of it. When you take an integral of this, we're not really getting into this plus minus business because we don't really care. Now, what I want to do is this. We have the ry plus k, right? The absolute value equals to you multiply r up to become rt, whatever. That's e to the power of rt plus this also c multiplied by r. It doesn't matter, just another we just call it another constant. We just call C1. It doesn't matter. It's another constant. We don't know this because we don't know the initial condition or whatever. So it's a constant. It's a constant anyway, right? It becomes this. This actually, when you write it up, it becomes plus or minus ERT plus C1. Right?
Yeah.
And also RT plus C1, this C1 just come out, right? C1 doesn't exist there. C1 come out becomes e to the power of C1 times e to the power RT. This equals to plus or minus e RT multiply e C1, right?
Yeah.
So we just, it doesn't matter. It's a constant is the constant. We'll call it C2, right? And now you get a k, right? You move the k over, this minus k, then you divide the r over, this is all divided by r, right? So y equals to plus or minus c2 e to the rt minus k divided by r.
Yeah.
So this k doesn't do much. We just carry it along. It becomes this. The constant is still not set. This makes sense, right?
Yeah.
Okay. Let me see what time it is. 16. Okay. We're gonna go to let's see what we're doing. Okay, we're gonna do one more, and then we'll quit. Okay. We do. In other words, okay. I'll say one more thing about this. When when there's a k, right? In other words, the change of y is proportional to y with a constant r. Also, there's a stage on it. When y equals 0, this already got a value.
Yeah.
Right? This k only comes to here. So it just lifts the y a little bit. It moves the y coordinates a little bit. The curve still looks the same way. In other words, it didn't change much. And if you look at this, you can imagine the same thing, right? Because when you minus something, you just shift this.
Yeah.
You shift this, and then in the end, of course, this curve just shift, right? Shift a certain distance. That all makes sense. Yeah.
Yeah.
So all the equation that we do, you need to have a picture in your head what's going on the graph. So we're saying geometry is everywhere. There's no algebraic and geometric difference. You everything you look, you need to know what this thing looks like, and whatever it looks like, you need to know what the equation is. Of course, a lot of things. For instance, like the way that the bacteria grows and with antibiotic worked in. When antibiotics is in the picture, because there are bacterial resistance to the antibiotic, it gets complicated. You don't have there are people come up with these equations, but these equations probably more approximate than just the bacterial growth. That's simpler. Yeah. 2 to 4 to 8 and stuff. So maybe you don't even have a equation for it, but from the data set you can come up with something. You can come up with a curve, just a curve, and you can say, okay, now for this curve, let's say everything. Let's say everything is positive. This is your estimate, right?
Yeah.
But then your data points on these points are higher. So maybe you just go higher here. You just like this, go higher, like that, right? But this is all just empirical. This is all by experiment. You don't know the equation for it. And then of course you do some approximation to it. See what kind of equation you can do with it. And then after that you can maybe you can do something. But we say last time the people's earning, right? Somebody make no money, and then there's some more, and then actually came down and then go up a little bit before it tapers off to very, very few. This is probably more exponential than anything else. Well, anyway, I am doing very bad exponential line. This is probably, this part, is exponential.
Yeah.
Yeah, for the fewer people that makes a lot of money. Here, the people make a lot of money. But over here, you can have theories.
But can't you just like cut lines, like just make it like x y equals to 0, and then like at this point, then make it like
Well, actually, we just said at this point it also all of a sudden jump because of minimum wage.
Yeah.
Then all of jump. I'm just saying you may not have an equation to describe this segment. Here is exponential. Here probably you can't describe it because there are multiple things going on. But you can have something. You can mathematically figure out a function to approach this. And once you have the function in your hand, you can try to explain it. What the factors are there? What are the factors that'll create something like this? So you can understand how these things play. You understand what I mean? How many? This is of course the people work. These are the bosses. Here's the bosses. People run business.
Yeah.
And then there's something. Actually, the population goes down with this. This is an interesting point. Then, of course, there got to be a curve about the people that make money and then it comes down. Here are all the CEOs and stuff, right? And then CEO actually becomes they own the stock of the company when the stock goes big, right? And all the CEOs are probably a curve like that.
Yeah.
Some CEO makes no money, but it goes up. And here's the peak, obviously. It goes to peak and then exponentially go down. It's probably not an exponential. It's probably a normal distribution tail. It's not an exponential tail. But anyway, we'll get to that next year. Let's see. What time? Okay, 22. Well, we're gonna break here a little bit, then we're gonna restart. See you next time.